when you take a portion of a curve that is part of a curve, like you can see in the diagram, here we have part of a parabola. Then we rotate that curve around the axes, in this case the x-axis. What we get is a three-dimensional shape. This three-dimensional shape is a solid of revolution. This particular one has been found by rotating around the x-axis. If you have a look at our formula, what we're doing here is we're working out volumes. So we're going to work out the volume of the solid of revolution. So what we have is volume equals the integral from a to b of pi y squared dx. The question then becomes, why the pi y squared? If you were going to work out an area of a circle, the area of a circle is going to be pi r squared. Pi is part of the formula for the area of the circle. R is the radius of the circle. If you have a look at our three-dimensional shape, it is made up of an infinite number of circles. Just like when we were working out areas, they were made up of an infinite number of rectangles. So what we have is the radius of the shape. The radius of the shape is the distance from the axes right the way up to the curve. That would be found by substituting an x value into the formula to give me the y value. Because we've got a circle, pi r squared. Now, if you think of the rectangles that were made up to give you an area, there was an infinite number of rectangles. If we took one of those rectangles and we rotated that around the axes, what shape we would get would be a little disc. That little disc is a cylinder, and the volume of a cylinder is pi r squared h. So looking at our formula for volume, there is the pi. R, as said before, is the distance from the axes to the curve. So that is the y squared. The height, like when we were talking about areas, we were looking at an infinite number of rectangles. The height is the width of the rectangle. That is represented by dx. So what we're doing is we're taking a very, 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 very small rectangles and rotating them around the axes to give us a volume. If you have a look at the formula, you can see instead of writing y, I've now written fx all squared.